Hello, in today's video we're going to be looking at how to process files that have been uploaded to S3 using Java and AWS Cloud. S3 is a hugely popular AWS service. I can't think of a customer that doesn't use S3. Whether you're in finance, retail, insurance, or building a new startup, S3 is probably going to be in the architecture somewhere. So today I'm going to show you how to use S3, AWS Lambda, and a Postgres database on RDS to process files and store them in a database. We're going to follow best practices where possible, but we're also going to make this architecture using the AWS free tier. So if you're new to AWS and you want to try things out, or if you're a student, this will be as close to free as possible. We're going to use a Java application deployed to Lambda using Spring, and we're going to use JPA to write to the database. This should all be pretty familiar stuff if you're used to writing Java applications. I'm going to show you how to test AWS components locally and how to deploy your application to Lambda using infrastructure as code. For infrastructure as code, we're going to be using the Amazon Cloud Development Kit, or CDK. This is a really great way of representing your resources or your architecture as code. I really like it, so I'll show you that today. If you're new to AWS, that's okay. I'm going to be explaining a lot of the concepts in this video, but if there's a bit that you're not familiar with or you need to research more, feel free to pause the video and come back later. I really hope that this is educational, and if you've got any feedback, please leave it in the comments. For the use case today, we're going to build an example car rental business. And this is going to be an electric car rental business. It's going to be called e-car rental, and when you rent a car from e-car rental, you can charge your car at a load of different suppliers. E-car rental has done deals with lots of different partners, and you can go charge your car wherever you like. Once your car has been charged, the way that the suppliers get paid is that they upload the usage data to S3, and we're going to build that integration today. We're going to build the integration that takes that CSV file that's been uploaded by the supplier and process it and put it into our database. Let's get started. Today's code will all be on GitHub, and I'll put a link to the repository in the video description. Let's have a look through how I've structured the project. On the left hand side, you'll see that I've got a folder for today's video. So S3 processing with AWS Lambda. And inside that, I've got two main folders, infrastructure and software. So the infrastructure folder will be where I keep all the infrastructure as code, and the software is where I keep all the application code. Let's start by looking through the application code. I've got two projects. One is the core application domain, and then the next one is how I use that domain with a Lambda function. So the domain is very simple. I have a class that represents the record in the database. So in this case, I've got a unique identifier for each row. I have an identifier for the car. I have a string for the supplier, and I have an amount of charge that has been given to that car. I'm using the Spring Assert library to do some null checking on the values, and I have some getters and setters just like any normal entity class. I have written the IDs as UUIDs, and again I've got my null checking on each of these. To store the data in the database, I'm using a CRUD repository. So I have a bog standard Spring JPA CRUD repository annotated with the repository annotation, and then I just have one additional query that I'm going to use to find all the records by the car ID, so I can find every single instance of a car being charged. The way that I like to structure my code is that I have all of the different ways all the different features of the application as different files in my feature package. So the first feature we're going to work on is recording car charged at supplier. So that is a very clear class name, and it shows the responsibility of that class. Again, this is annotated with the service annotation so that I can dependency inject my repository into this class. And from there, again, very simple, we're going to take a supplier charge record, which has all the information I need to store in the database. And then I'm going to create my domain object and then save it to the repository. I'm going to log that that's happened just to help explain the application, and then I'm going to return the new ID. Now, already this is using an external third-party process with Postgres. So how am I going to test this? Now, you could test this by using something like Docker Compose and standing up an application and a whole database. The way I like to do it is using test containers, and this will show even further on in the video when we use test containers and local stack to do S3 testing as well. In this case, this is just going to create me a Docker container with a Postgres instance, and then I'm going to inject the URL, username and password using dynamic property sources into my Spring application. Okay, so when this test starts, I'm going to have a Postgres database, and then I can test my code against it. I have a single test case at the moment, and we're going to create a supplier charge record with a new car ID, our supplier name, which is quick charging, and the amount of charge that that supplier has given to a car. We're going to use our feature, which is record car charged at supplier, and then we're going to record that in the database. We're then going to use the car charge repository to grab that record by its ID, and then just do a quick assert that the correct charge amount has been allocated to that car. All very simple, but this is a great integration test to make sure that everything's working as expected. So let's run this. Here we go. Green tick, all successful. So the database has been bootstrapped, record has been inserted, and then we've selected the record back to assert that the value is correct. All good so far. Okay, so we've written our application and it's ready to go. How do we integrate it into a Lambda function? Well, today I'm going to show you how to do that with Spring Cloud Functions. Now, you could do this without Spring and just write a plain old Java integration, but I want to show you how to use Spring today so that we can use dependency injection and inversion of control. I want to be able to wire in my features and my repositories and make it easier to do that. So this is what the entry point of a Lambda function looks like when you're using Spring. I've got the Spring Boot application annotation, and importantly, I've got a function which is annotated with the bean annotation. So this is the method that's going to be invoked when somebody uploads an object or a file to S3. And we'll go through how that configuration works when we go through the infrastructure as code section. But ultimately, this is the function that's going to get invoked when a file is uploaded. And what's going to happen is that your function is going to be invoked with this S3 event object. And this S3 event object has a pointer to the file that has been uploaded. It isn't the actual file, because S3 objects can be gigabytes in size. So even though ours is going to be small, this is just going to have the information that we need in order to download the real file. And that's what we do further down in this application. It's not particularly interesting. You can go have a look at the code on GitHub if you're interested, but ultimately we're going to use an S3 client, which is part of the AWS SDK, to download an object. And what we need to do that is the bucket name and the object key. And both of those are from this S3 event object. Once we do that, we can use our CSV library to cut up the data and take each row and ultimately call our feature, which is record card charge that supplier. Okay, so I'm taking all the information from each row and I'm calling our feature. So now I have an application that not only speaks to Postgres but also to S3. So how can I test that this works without spending lots of time going backwards and forwards with AWS? So the way that I like to do this is with test containers. And again, I can use test containers and another open source project called LocalStack to create a container that has a mimic of S3. Okay, so I can use this mimic of S3 instead of the real S3 in the cloud. So this is going to be another container that's running on my machine, and I'm going to alter my S3 client to speak to that mimic service instead of the real service. So you'll see here that I am changing the endpoint to the local stack endpoint and providing some dummy credentials, providing a dummy region. So these aren't real credentials or real information. They're just to fool the client into thinking that we're speaking to S3. We're really speaking to local stack. Once I've done that, I can then create my entry point of my application and pass in a auto-wired copy of my feature and the new S3 client that I've configured to speak to local stack. Now I want this to be as realistic as possible, so I'm actually going to add my test data, which is a CSV file. Looks a little bit like this. I'm going to add this to the local stack S3. So in this method, you'll see that I am making a bucket called bucket, and I'm putting my test data into S3. And this means that when I invoke my my application, it's going to have to go download that information from S3, and then I can test the entire end-to-end process. The application is going to download from S3, it's going to process that data, and it's going to write it to the Postgres database. And then finally at the bottom here, I can use the car charge repository to find the information that I'm looking for and just validate that the right amounts are there. Let's run this to see if it works. So this test takes a little bit longer because not only am I booting up Postgres, but I'm booting up a container with S3 in it as well. But I've got myself a green tick. Everything looks good. Okay, so we've written our application. We've integrated it into AWS Lambda using Spring Cloud Functions. Now it's time to deploy all of this to AWS. And the way we're going to do that is using infrastructure as code so that we can make the process repeatable. We don't want to be going into the console and clicking buttons. We want to use an automated approach to our deployments. So we've got S3 bucket, Lambda function, and an RDS database. Now it may seem simple from this small diagram, but what we're actually going to be producing for our real solution is more like this. We are going to have our Postgres database on an EC2 instance, and that's going to be in a private subnet. So it's not going to have any outbound access. It's not going to be accessible by the public internet, which means that our Lambda functions also need to be in the same network space. Okay, so our Lambda functions are going to be VPC attached. They're going to be isolated and they're going to be able to speak to the Postgres database. This database security group is going to allow access from this application security group. So from a security point of view, we're very isolated, we're very compartmentalized, and there's no outbound access. But our Lambda functions do need to be able to access external services. In our case, we need to be able to access S3. So this wouldn't be possible in a private subnet unless we had a VPC endpoint. So we're going to add a VPC endpoint, and then we're going to be able to access S3, and we're going to be able to do our work. Okay, so let me show you what CDK code looks like. Now, our CDK code consists of an application, and within the application we're going to have, well, I've designed two stacks. So I've split our architecture into 2 bits basically, and the way that I've done this is I put the networking aspects and the database in one stack, and then I've put our application in another stack, because I think I'll be changing the application a lot more than everything else. So separating the two makes it easier for me to change, and means that I have a smaller blast radius if I make a mistake. Okay, so let's start with the infrastructure stack. Now within the infrastructure stack, I am creating a VPC from scratch. So most likely if you're building a new application, you probably have VPC infrastructure existing, and you'll probably add to that. But if you're a student or someone who's learning AWS, you can run this example and it will create you a new VPC. And you'll probably notice that there isn't a lot about CIDR ranges or which subnets. A lot of the configuration is done for us when we specify certain attributes about a database or a Lambda function. So if we go back to the database instance section, this is how we specify that we want a Postgres database. So this is the database engine, and we want it on an instance type of a T4 graviton, and by using the micro size we get to use the AWS free tier. And then this is put into a subnet because I'm specifying the subnet type here, so private isolated. So this has no public access. And it's the same with my Lambda functions. I'm going to use the same subnet type in my Lambda functions. So this is all code that describes the infrastructure of my system, and I can use the CDK command line to deploy this infrastructure to my cloud account. A couple of interesting things that you also probably want to note is that we are actually creating the database secret using AWS Secrets Manager. So I'm creating a strong password here, and that's going to be stored in Secrets Manager, and I'm going to pass that to my Lambda function. So this is my infrastructure stack, and then my application stack is here. So I'm creating a new S3 bucket, and then this is the configuration I have for my Lambda function. So let's go through this in a little bit more detail. So I can specify any particular Java runtime. We have all the major LTS versions, so 8, 11, 17, and 21. I can specify how much memory I need. I can specify my timeout. I then have to specify the location of my code. So in my case, this is the Spring application that I have, and this is the location of the jar file. This handler is a reference to the Spring class that's going to do all my magic. So this is the Spring class that knows how to call my application. So bit of a magic string, but at the moment while you're learning, just add this in. And then the second thing is that you need a reference to your Spring application class. So this is my Spring application class. Again, we're going to put this Lambda function attached to a VPC, and we're going to put it in a private isolated subnet. From there, here comes the magic of how to integrate a Lambda function and a S3 bucket. We're going to use something called an event notification. And it always blows me away how easy things like this are in CDK. So this is a reference to my bucket, and I'm simply going to add an event notification whenever an object is created. And what I'd like it to do is to send that event notification to a Lambda function. And in my case, my Spring Cloud Functions Lambda function. And I can actually also filter as well. So if I only want CSV files, in case other files get uploaded by mistake, or if the bucket is being used for multiple things, I can say I'm actually only interested in objects that are created that are CSV files. And finally, if anyone's ever been frustrated with IAM permissions and making sure that the IAM permissions for things are correct, this is all of the IAM permissions that I need to write for this application. And again, I find this amazing that it's so easy. I have a lot less IAM permission problems than I used to do now that I'm using CDK. So again, I can say CSV uploads bucket.grant read access to my Lambda function. And that's it. Another really cool thing that we can do with CDK is that we can add tags to every single resource that we create. So instead of going through each resource and adding the tags individually, we can use this function to tag every resource in each stack. And this means that we can have a really good understanding of what is being created in our AWS account. It also makes it easy for us to understand the costs associated to any projects. Now this project is using resources that are either on the free tier or very minimal costs. But if you were making a larger application, or if you were building on top of this application, this is a really good way of making sure that you understand what resources are being created, and ultimately once the application has been removed, to make sure there's nothing lingering in the account. So if I jump over to the console, I can use the resource explorer, and I can search for all of the resources with a specific tag value. And here you'll see all of the different resources that I've created. Obviously a lot of these are to do with networking, but you'll also have the VPC endpoint and the Lambda functions. Okay, so this is a really good way to make sure that you're not ever losing track of what you've created, or having a cost that you're not expecting. At the end of your time experimenting with this application, I hope that you use CDK to remove all of the resources that you've created. Although they should all be on the free tier, it's hard to understand sometimes when the free tier ends, or when you add additional resources where you may start incurring costs. So I'll include instructions on how to remove all of the application from your AWS account, so there's nothing to worry about. So in this video, we've created a Java Lambda function to process S3 files that have been uploaded. We're using Spring Cloud Functions, test containers, and Postgres, using JPA to write the data. I hope you found it really interesting, and there's lots more topics that we could go through together. We haven't even touched observability or performance. If those are topics that you're interested in, leave a comment below. All the code is on GitHub, and I'd really like you to go through it and understand it further. I've not, for example, talked about any of the dependencies that I've added to the project. You can look those up yourself. I have left one thing for you to think about. I've made quite an obvious mistake with regards to the secrets manager and Lambda configuration. See if you can spot it and leave a comment, okay? And we'll fix it in the next video. Thanks for watching. If you can subscribe, that would be fantastic so that you don't miss any videos in the future, and give me a like if you've appreciated the content. Thank you.